go.
I want some popcorn. So this is Rachel McKinstry doing a Rube Goldberg machine for popcorn.
Get out of the way.
So, while that just finishes popping up some of the last few kernels while the heat's still there, before I eat it as well, I have to explain the physics concepts behind the entire machine. So the first part is the ramp with the car, and this one works with several different physics concepts. These can include gravity, potential, and kinetic energy, inelastic collisions, velocity and acceleration, Newton's first law and Newton's third law. So the gravity occurs where it's pulling it down towards the earth. During the ramp, it continuously moves downwards, so there's gravity's effect. Potential energy is when it's at the top and it isn't quite moving. This means that it has the potential for quite a bit of energy, enough to push the counterweighted minion off of the table, which starts the whole machine. And then there is kinetic energy, which is happening as the cart moves down the ramp and as it continues moving across the table until the point of contact. Velocity and acceleration both occur during the ramp, where it is being pulled by gravity downwards, so as it's pulled down, it accelerates. Newton's first law, or inertia, is when an object will remain at rest unless acted upon, or it will remain at motion unless acted upon. This is mainly for when it's placed on the top of the ramp and then I let it go, which allows it to roll, or when it makes contact with the minion, which means that the minion would be acted upon by an external force, which would be the cart. And then Newton's third law, for every action there is an equal and opposite reaction, is when it pushes the minion off the table, but it does also get itself pushed backwards. And then there is the minion, which is mainly under the force of gravity, but it does receive the end of an elastic collision with the cart, and Newton's first law, which means it wants to stay there unless the cart with the golf ball makes contact and pushes it off. Now the cart, when it makes contact with the minion, it has linear momentum, which means that it wants to keep going, but because of the elastic collision with the minion, it will be pushed off and effectively stopped. And then again for the minion weight, just Newton's first and third laws, which would mean basically it won't move unless acted upon, or it requires a force to push it, and it produces an opposite force to whatever's moving it. Next is the pulley system, which is hanging from the chandelier. The pulley system relies on the gravity which pull from the minion, which then pulls the cart track upwards, and it means that the car battering ram can then actually move properly and have enough force to push the ball down the ramp. The ramp is mainly, again, gravity, but there is velocity and acceleration from the initial point of contact, where it will accelerate down the tube before making contact, and inelastic collision with one of the final parts of the entire machine. Now, it does also have potential and kinetic energy. When the potential energy is at the maximum, it is in the little cradle at the end of the track, and is given kinetic energy during its downward descent down the tube. It also has linear momentum, which means that it wants to keep going, but it makes contact with the battering ram bottle. But there's also Newton's first law, again, inertia, where it doesn't want to change its movements and it wants to continue being at motion until it makes contact with something else that will stop it, which is, again, the external force, which in this case is the water bottle that stops it dead and collects the energy from the marble in this case. There's Newton's third law, which is equal and opposite force, which is where the car makes contact with the marble, pushing it down, but it also pushes the car backwards. And then when it makes contact with the water bottle, which pushes the water bottle forwards into the popcorn maker, and it jumps back slightly but rolls down the slope to come to rest. Then there is the water bottle battering ram sort of contraption. This mainly operates on gravity, which is what enables the water bottle to stay in the position of which is required. It has an inelastic collision with the marble, as previously stated. It has the Newton's first and third laws again, which is basically it has to have some sort of force applied to it. Then finally is the popcorn maker. This runs on convection, which is when a fluid is heated and then it travels away from the heat source, which is when the popcorn kernels pop and they actually come out as the popcorn we know. Thus allows the actual kernels to come to the bottom and be heated before they actually pop as well. It also relies on Newton's third law, which is when the button at the back is put in contact with the water bottle and it is forced to turn on, and it jolts the machine a little bit forwards. And then again in an elastic collision from water bottle to the button to turn on the maker. It relies on heat, which is thermal energy in transit from one object to another, to pop the kernels, which actually have quite a bit of thermal energy when they first come out. It has a phase change, which is when enough heat is added to a sample of matter. The sample will eventually transition from one state to another, which is from the little kernel that goes into the white fluffy popcorn that comes out. It also follows the first and second laws of thermodynamics. So the first law is thermal energy cannot be created or destroyed, only transformed into other forms in a system in simple terms. So the energy is transferred from the popcorn maker into the kernels, which allow them to then change form. And then the second law of thermodynamics, which is basically when heat never spontaneously flows from a cooler substance into a warmer. The kernels are cooler than the popcorn maker's production of heat, so the heat will then flow into the popcorn kernels and they will continue to heat up until they actually pop. So, and they become an equal temperature to the heat being produced, and that's when they sort of jump out of the dish and fall into the popcorn thing. So thank you for watching my demonstration of a homemade Rube Goldberg machine with parts that we had at home due to COVID-19. And thank you to my parents for letting me take up the living room for setting this up, but I'm also rewarding them with popcorn, so it's all good. Anyway, thank you.